Hello and welcome to another Odin demo. Today's demo is I'm going to be showcasing what is in version 0.3 of Odin. It's amazing how far I've already got, and the language itself is nearly a year old. It's going to be a year old at the end of this month. Wow, it's gone a lot far so far. So, let's get started. So first I'm just going to talk about some of the minor features I've added. So because there's Unicode support in the actual parser and stuff, when the tokenizer and stuff, I've added some lexical sugar for some of the operators. So you can write this as not equals if you wanted to. You can do this as less than or equal to, or greater than or equal to. These will work as well as the original ones, which would be that, that, and that. But if you want it to look pretty, you allow it anyway. It's just a little bit of lexical sugar. That's all it is. The other thing I've changed is the label syntax. So you now just do it as a name, so name colon, and then the label itself. So before you had to prefix it with a hash label, then the name. This works now. It's just easier to look at, and in my opinion, prettier. So it's quick and easy. I've removed the keyword for no alias, and have now just made it into a hash directive instead. So no alias is when you apply it to parameters. So to say none of these pointers will alias. It's the same as equivalent to C99's restrict. I've re-implemented ordered. I halfway through one of the versions I disabled it and now re-enabled it. Ordered so it's C-like structure syntax. I've added bits, which is a nice, lovely library with loads of bit information in it for intrinsic. So you've got count ones here, you've got count zeros, rotate left, rotate right, trailing zeros, reverse bits, byte swap, eddyiness stuff, overflowing adds. So these got the overflowing operations. So if it overflows, it returns a bool as well, and true or false. So they're very useful to have in bits. So if you ever need to do anything low level, do use that. I've also removed another keyword, which is default, and replace it just with case colon. I nicked this idea from watching the latest JI stream that John has done, and just realised, yeah, that's good enough. I understand why default was there originally. It came from C, and it's very clear. Yeah, I saw a lovely artifacting going on the screen. You gotta love Twitch. So I've now added XOR for boolean, so exclusive OR. Originally you couldn't do it, so an exclusive OR in this syntax, as you hopefully will know, is that. That is exclusive OR. So if that is true and that isn't true, or vice versa, then this will be true in tail. But if they're both either true and true or false and false, it'll be false. So that's what exclusive OR is. Hopefully you understand that. I've done numerous bug fixes as well, so there's been loads of bug fixes to FUMT and a few of the math libraries as well. I've also removed the quaternion type. So originally quaternions as a kind of a joke. I added them as a kind of April Fool's joke, but not really. It wasn't April Fool's when I actually added it, but I liked them, so I added quaternions as an actual core type. Now I've removed them. I'm going to add them into the math library as just a user level function type, but that's fine. So the other thing is I've now made runes, which is a Unicode code point, as a core type. Originally they were an alias for an i32, so a 32-bit integer. I've made them a core type to give them extra type information. So when you're passing it to an any or something in a print line function, it knows this is actually a code point, so it has a bit more information. And I've also removed byte because again byte was just an alias for u8, and I didn't really want aliases because the user can't implement them. So why have something special that the user cannot do, in a sense? So let's talk about the first cool feature. And these are 128-bit integers. Now, many languages do not support these, but they are very useful. So a lot of the time, you may want a lot of high big digits. Instead of having resorting to a big numbers library, 128 bits is probably enough. 120 bits is also great if you are trying to record time information. So 120 bits is enough to calculate a number of nanoseconds since the beginning of the universe. So it's a good enough thing. So if a normal 64-bit integer wouldn't be enough. And now, just to prove that these work, I've just got some big numbers, and you'll see how big they print out. That number would not be able to be stored in a 64-bit integer because it's more than about 20 bytes? 20 characters would be a 64-bit integer, yeah. And you see it works fine. So they're the two that are great. Let's scroll down slowly. Now let's look at the second thing I've added, which is the divisor-based modulo operator. So normally modulo is here, and this is a dividend-based modulo. So this is what you'll be like in C or C++ or modern C and C++ and other languages you'll be used to. So when you do something like 5 mod 2, if this one is negative, you'll get -1. Now, a lot of the time, you don't want it to be dividend-based, you want it to be divisor-based. So you kind of want to be thinking of it as in block increments. So you go from, it'll always be 0, 1. If it's from mod 2, it'll be 0 and 1, 0 and 1, 0 and 1. There won't be a negative value unless the denominator is negative as well. So in this case, -5 mod 2 is 1. So if we made this to be 15 and then 7, -15 divisor-based mod 7 will equal 1. Oh, that's probably a bad one. Let's try 5. That was an awful idea. Why did I do that? Yeah. Is that working? Is that working? Yeah, it's working now. Sorry, that was a bit silly of me. So now it's working. Yeah? So the way you implement a divisor base for signed integers, at least, is it's the mod A mod B plus B mod B again. So it's always positive if the denominator is positive. If it's not positive, it'll work like that. So hopefully you'll know how it works. Yeah? Sorry, Vasvik is saying, why do you need that when that's only 40 bits of information? Because when you multiply them together, you'll get a number this big here. And that will not fit into a 64-bit number. Hopefully it makes sense. So yeah, and then Cubical was asking, why didn't you call this the remainder and this the modulo? Because I just want to explain it, because when you search what modulo it is on things, like in internet terms, they'll always refer to them in this case. It may be better in the documentation to refer to them to. So if you've got any more questions, again, please leave them to the end. I've got loads. Sorry, I didn't really see the kappa thing then. Whatever. So, another bit of syntax change, just minor things. It's casting syntax. So originally I had this like prefix thing. So I had a keyword here, then you had the parentheses and the type and the expression, and that would be your type. And it was very consistent. So you had a cast, transmute, and union cast. Again, referring to a regular, a bit cast, and a union cast. Now, I wanted to change this to make it a little bit more terse and also allow for extra things, because a union cast only works on unions, and I wanted to also work with like an anytype, because an anytype is very similar to a union in its kind of use in a sense, so I want to do that. So for a regular cast, I've just changed it to look like a function call. So you just specify the type on the left, put parentheses, and then put the expression in the middle. So this will convert this float into an integer. Really simple, really nice and terse. You don't have to worry about this big old clunky cast now at the beginning. Bitcast is now kind of a built-in function instead. So instead of being a built-in keyword, it's just a function which you pass it a type and then the value. Again, not much different. So now type assertions, which now replace a union cast, the syntax is slightly changed, and this is so it's not kept to be a union. So let's take this entity here, which is just a nice little union, which has a tree and a frog as two variants. Just pretty nice to do. So we have an entity, and then we're going to store in this frog here. If we use this syntax here, so we've got e dot, and then in parentheses the type, this will be a type assertion. So it returns a frog and a checking value. I'm going to check the value and see what happens. And it says, Trevor the frog ribbits, and I put parentheses in there, ribbits at that volume, whatever. Yep. Yeah, there you go, and you got to check. Now, if it fails, you can also do without the check, and it will do a panic if this fails, if this is not the correct type. So if I do a tree, it'll say it crashes, and it's crashing, and it doesn't work. So this is a type assertion error, entity to tree. So it gave me a proper error. That was good. Now, the other reason why I've changed this syntax is so I'll allow it for any. So if you've got any here that's called foo, and you've got type of any, and you've got like that, you can also do the same check with this here. So you can see it says foo equals 123, just to prove that's the case. Let's change that to an F32. It won't pop up. Yay! So now another little more syntax change. This is just, the big features have taken a little while to implement, so it's a bit annoying. So syntax changes, as I talk about here, originally I had the caret to represent 3 different concepts. It represented pointer types, pointer dereferencing, and addressing of variables. Now, many people actually like this, but I found they aren't orthogonal concepts at the end of the day. And because of this, it is overloading the idea of what this pointer caret does. So I've separated the concept of addressing a variable to be represented as an at. This ampersand here, so this ampersand, yeah. So this is because the concept of pointer getting an address is quite weird, really. It doesn't actually fit into a normal type system. And it's consistent with the people in C. So just to show how it works, here's a variable of an int. Here's getting its pointer, and that is the pointer type. And then you're dereferencing on the right. Yeah? So that's a nice little thing there. So for consistency, this allows for a lot of the things. So if pointer on the left, it just means a type, you can do a nice little typecast like this. Without it, you would have to bracket the type. So kind of like seed-like. But in this case, you can just write the type and it works. But the main reason why I quite like it is consistency. This is nicking the idea from Pascal style languages. So if you look at an array, you'll notice that the braces are on the left of the type, and its usage is on the right of the type. So it's the same with pointers in this case. The pointer, the caret, is on the left, and its usage, making it dereferencing, is on the right. And I quite like that. The addressing operator, again, it is a very weird concept. It has no kind of any other analogy in there. It's kind of saying, hey, this is a weird operation. Find us the address of this. In many type systems, it doesn't. It's just weird in a sense. It's just weird. But you do want it because it's a very, very useful construct to have. So another minor difference I've done in the syntax is of allowing people to access members of like a record through a number. So here's a tuple-like object. So this is a structure where all the fields have no names. They're all anonymous. But you can set them up with a 0. So when you print this tuple-like object, you get this here. You see all the numbers get stored correctly. So accessing with a number is fine. This also shows that you cannot start a floating point number with just a point. You have to put a 0 at the start. I actually am forcing a style there, so that's not a problem. So one of my favourite new features that I've added are bit fields. So in C and in many low-level languages, you want to be able to manipulate the actual data at a bit level. So let's say you're storing this data here, and this is a compact data that you've got over a network or such. And to keep it packet size small, you're storing as much information as you can in the actual bits. So this may be an example. I actually pulled this example off Wikipedia, just as a little one. And then I'll show you kind of more realistic example down below. So here we go, you check your opaque, and really that's just a Boolean value. You want to set just only storing 1 bit. You can have fill color, so this only requires 3 bits, so that's 3 bits is 0 to 7. I'm doing a padding value here, that's what the underscore does, so pad for another 4 bits. Show border is just going to be a Boolean. We can go to the border style, you can go the width and height and so on. These are all different things. And you can notice you can just store them as if they're integers. One good thing is if these are constants, it'll check to see if that'll fit in. So if I write let's say big number for show border, and show border is clearly only 1 bit, so it can only be 0 or 1. It says, cannot assign this to bit field properties there. So it's too big. It's too big to assign, but you can do 1. Can't do 2, but it'll do 1. And you can see it prints it and stores it correctly, so width is 12 and height is 10. So one of the big good use cases of this is for getting the bits and stuff of like floats and stuff. So if you're doing a lot of formatting with floating data, you may want to get the fraction, the exponent, and the size, or the mantic, so if you want to say instead of fraction. Sorry about that, I was a bit, I had to do a thing there. So you want to get the information here. So if you just take a float and then you transmute it here, you can do the bits here as well, it's the same thing. You can get individual data from it. So you can get its fraction, exponent, and you give it the sign. So I'm just casting this sign to a Boolean. This will work if it is 1 bit. This is only works, so if it was more than 1 bit, you wouldn't be able to cast it to a Boolean. One thing I might also add here, as I don't know why I didn't do this, is I could put an alignment on there as a requirement. So you can see here this does actually line up. So you can see the numbers are the same, except there's a 7 there instead of an F, but that's because you'll notice that's 23 bits, not 24 bits. So it couldn't get the extra information. So that's a nice feature. This took a while to implement, and I think there was a bug in here. I know there is and I just haven't found it. But it's a very useful feature, and many low-level system languages don't even have it as like a core construct. Like Rust doesn't have it. It does have it as its like macro thing, but it's meant to be a systems language, and it doesn't have the ability to do this. There we go. So, naming conventions. This is just something, trying to kind of do a bit of a standardization through the library and the languages. So, Odin, in the chat on the Discord and stuff, we finally decided upon official naming convention. So, in general, you'll be using a Pascal type, so upper camel case for types, and snake case for values. So, this is very, very similar to Rust convention. So there is a difference between types and values. Originally, I was using kind of Ada case instead of Pascal case. So the difference between Ada case is you just put an underscore between the separations. I actually did like that. I wanted to keep it simple and also a bit more useful compared to most other languages. So as you can see here, we've got import names are going to be value-based, but again, prefer a single word. Types are going to be Pascal, union variables are Pascal, enum values are Pascal, procedures are snake case, local variables are snake cased, field variables are snake cased, and constants are screaming snake case. So just say, look, clearly this is a constant. There you go. Yeah? I do like Ada case, but I think it needs to be a little bit different. As well, just only a little bit different. So that's done for this version here. There's been a lot of mainly bug fixes and literally in the compiler differences more than actual language features. So let's talk about what are the goals for next time. So for version 0.4 and further on in the future hopefully as well, I'm hoping to compile the compiler as C++. Because I mainly want some of the sanity features from it, such as overloading. So I want to make sure that the generic array type that I use has a bounds checking to it, just to see for extra bit safety, only a little bit more safety, and I can always disable it in like release builds. I also want to have a map type, which is like, again, a template, and I'm using a template just so it allows for self-documentation, rather than I have to write loads of comments saying all of this and this. It is just self-documentation at the end of the day. In my compiler, I actually very rarely use the actual built-in map things. I'd have to instantiate them every time because I'm using an X macro. This is just in the compiler, so it's not for them. Worry about you. The other thing I want to add is to change the context system from being a thread base, or like through thread local storage, to an implicit parameter when you call a function. I originally had it as thread local storage because I just didn't want to make a new piece of data every single time. But the more I've thought about it, the more I think an implicit parameter to a procedure is a much better option. Because it allows you to go check through the call stack and see what the previous values of the context were, if they changed. You can also pass extra information to it. You can do a lot more to it. You can actually change the value at a scope level. You don't have to do these like context switching in a sense with the thread local storage. The other feature I want to implement once I've actually got the sanity features done in C++ is parametric polymorphism. So I want to be able to pass a type, literally a type, to a procedure, so I can have an explicit form of like generics rather than an implicit version. So the user could easily create a new function like this. So instead of me having to write new int and it was a built-in function, the user himself could do that. So I could just this is pseudo syntax, by the way. So type. It's probably not going to look like that. That's what I'm going to explain in a minute. Alloc align size of t align of t, and look, new is now implemented in the actual language, and it's just user level construct, and you just pass that type in. So there you go, it works. And this would also allow you to have generic sorting algorithms, and I also want this to work for types as well. So you can have like a generic type. The other thing is I want to also decide upon declaration syntax. So if you've been listening to the chat, they've been talking about Fleeman syntax lives matters, because I've been thinking about this and contemplating changing the declaration syntax. So this will need a little bit more explanation to do. Yeah. Right, so Odin at the moment, let's just scroll down here. Odin at the moment has a very unique syntax for declarations. So I kind of nicked the idea from JAI and modified it a bit to make it consistent, because JAI's syntax is nowhere near consistent, and nor is it easy to parse because it'll have ambiguities in it. So I made it more consistent. So first off the bat, if you want to declare a variable there you go, there's a variable in Odin. You could have a constant, so this would be a constant. You can do that, but you can do an implicit type in the middle here. This is the same, they're explicit types, and then you could do this with an implicit type, so you just have to emit the type. That's all you have to do, emit the type between these operators, where that's it. If you want to do a type, this is where it starts getting a little bit ambiguous, because at the compiler level, at least like the syntax level, the user cannot know if the thing on the right is a type or even just a value without going through the semantic level and checking it. So that's one problem you have. I have an entire gist, in fact, I've just realised, or a gist, or however you actually meant to pronounce that word, talking about this in general. So I'm just going to copy and paste this in. I should have done this before. Planning is always good. So this is how we're doing it. Current Odin syntax style. There's variable declarations. There's a constant declaration. There's a procedure declaration. So if you want a procedure, it's like a procedure literal, but you're assigning it a constant name. And then you're also, if you want it a foreign, so it's elsewhere, you swap the body for a foreign tag. And then type declarations are a little bit complicated. So you'll notice here that it says my proc. even the syntax highlight is having a struggle here, is that the difference between a procedure type and a procedure declaration is very, very small. It's very actually difficult to know. It's not hard to parse. It's just it's not clear to the user. I think it's gist, like in a gist. I'm thinking, yeah, that's how you do it, yeah. But so it's a bit ambiguous. So if you just had the braces here, it would have been fine. There wouldn't be any ambiguity between that and that type. But because I allow foreign variables and I kind of need it in this syntax, and this is the only way you can do it, there's where the ambiguity lies. So to make it a little bit clearer to the user, I allow these helper tags. But in a struct type's fine. You know that's clearly a type just by looking at it. It's just when it's a case like it could be an identifier, like an int, or it could be a procedure. It's a bit odd bit. So again, I explain the advantages here. I have a limited use of keywords. There's a consistent distinction between variables and constants. So these things can be changed in memory and stored in memory. None of these are stored in memory, kind of. They name themselves. They're just constants. They will never change. It's quick to type as well, because you just think name, colon, type, equals, and then the value. It's just quick. And again, it's very clever with its omission of types. Again, so many interruptions tonight, and I apologise for that. But yes, so that's kind of, again, I've already talked about the problems. It's ambiguity between procedure types, declarations, and foreign procedures. Again, it's unclear if this is a type or a value, even at semantic, you have to go through the semantic checking. And one amazing thing that allows in this syntax is that you can do that. You can say, okay, that's a type and that's a variable on a single line. Now, if that's not confusing, that's like, what? Okay, so I have this is one of my ideas for prefix style. So most modern languages seem to have converged on this in some manner of sorts. So this is my idea for a prefix style, and it may modify it different. So what you do is each declaration is prefixed with a keyword. So variable declarations are prefixed with a var. Constant declarations are prefixed with a const. Procedure declarations with a prog. Type declarations with a type. Now, with type declarations, you could have an equals there just to make it a little bit more consistent, but it is kind of a redundant thing there going on there. But so the difference is here, it's consistent. This is how kind of like Rust works, how Nim works, how Swift works, how God, the amount of languages that actually have this thing, and there's a reason for it. It's pretty easy to parse. All the different types of declarations are different, and again, it's very consistent. There's a distinction between the declarations, similar to modern languages, and it removes some of the disadvantages of the previous one. Now, there are some big problems that come along with this. The big thing is it introduces a lot more keywords, so it reduces what your identifiers can be named. Especially introduces the keyword type. Now, type is a very, very useful, it's a common way of typing things you want to write. So a lot of the time I have to use the word kind instead of type, or I have to write type with an underscore or drop the E just so I can get it. Now, again, it's one of those where it's like, oh, this is annoying. I have to decide which one do I want, what I don't want. It's like, eh. And again, it's also more to type is another big disadvantage. So many people who are used to writing, they may think, there's only 4 more characters I've got to write. But yeah, it's 4 more characters you've got to write. Compared to the previous style, that is extremely terse to write. There's a new variable, done. If I want to do that, I have to write var at the start. And that's, again, another 3 characters. It's a lot at the end of the day. So looking about the other goals I wanted to talk about. Sorry, I'm jumping around now. I forgot. I should have put this the thing at the end. I also wanted to, for the further languages, I want to get a better import system with a solution for packages and modules. I actually want to figure out. I want to figure out what constitutes a package. Now, many other languages do different ways. Like Go has a directory is a package, but I want the ability to have single file libraries as well. And the way that Go does it makes it impossible, pretty much. It's really difficult to start, and this is why I need a real big discussion with people, like face to face, and talk about it, because it's not easy. It's not an easy problem. The other problem is I also want a better foreign interfacing with C, and maybe even C++. So you could even have some of the special things in C++. But again, the syntax at the moment doesn't actually really allow for it. The prefix syntax actually would allow it, so you could have like a foreign block and define all the foreign things in there, and it will just do its magic. With the current syntax, you have to do all these tags at the end, and even it's not that. Oh, it's annoying. Oh, there's one thing I forgot to add on here, which is actually quite important. Attributes. I'll talk about that in a minute. So the other thing I want to do is a documentation generation system for the code. So if you have a library or something, you can just say, hey, generate the docs for this, and it will just generate the docs. The docs will be just comments attached to the actual entities, the declarations. I also want to do a general documentation for Odin. I'm actually working on the website at the moment. I've also just bought 2 domain names. So there is a domain name for the Odin language site. And when the website's up and ready, there'll be some demos, there'll be some exhibitions of people's projects already done in Odin. There's somebody in the community, Vasvik, who's already got the Oculus Rift working with Odin, which is amazing. I'm going to show one of my projects. I'm not going to say what it is yet. There's some other people showcasing. It's great what the community's actually done already. But yeah, that's one thing I want to do. And the other thing I almost forgot was attributes. So this was a huge request from Mikkel. Or this drunk Dan or Hyochu, whatever he's been called by on whichever social network. And attributes is where you can associate extra data to a type or a declaration. So a basic attribute for a procedure would be say, hey, this needs to be inlined, this doesn't need to be inlined, this is blah, 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 linking names different. That's a simple one. But something different is you could give these things different data. So you could actually analyze the code. So you can say, okay, get me all of the types that have associated with a certain tag or an attribute, and collect them all up and search them that way. It's the problem with it is it does require a lot of extra memory. But if this language is going to be designed towards more desktops in general, but also allow for lower them, I should be able to disable attributes. So it's really, again, it's something to think about. It's a quite complicated topic to think about, but it should be a very useful thing in the end. Searching the actual code. You'll be able to search your entire code, but that will increase the binary sizes and stuff, and I'm just not sure if it's worth it or not. But okay, that's about it today. Again, thank you for listening. I think it's now time for questions and answers. How is everybody doing? So let's see what questions people have got. We'll just go through it. Vasvik is already asking, can you iterate through members? Members of like bit fields and stuff I think you were talking about. The answer is yes. So if you go here, the preload types. Oops, that hasn't been updated, but to the right calling convention. Oh, that's funny. Whoops. Set syntax, not as Odin. There you go, Pascal case. There you go. Just should have updated it. Whoops. That should still compile. No? Yeah, that's not even real code. What am I talking about? Go away, dead code. Go away. Go away. Of course it's not going to compile. So, back to the preload. If you go into here and you go into bit field here, you've got names, bits, and offsets. It'll be the offset and bits. These are the size and bits and the name. So yeah, you can iterate across them. So I'm just looking through what questions there are. Someone's asking is if you pass the context through a register, then you put even more pressure on the already few x64 registers. Not necessarily, because you just probably make it as the calling convention. So you just pass it like a normal variable. I'd pass it by pointer for definite. And if you use that, then you make a copy on the actual thing, because you may not use it. So you can just keep passing the context through. If you don't use it in that function call, then it's no extra cost. Passing a pointer is goddamn cheap. So again, it'll just be passed on the stack anyway. And if you don't want it, you can always just say, but with a calling convention, you could have an Odin no contextless calling convention. What else is there? So name guy 101 is asking, why, if you're doing the prefix style, why does var x colon need a colon? This is mainly, it technically doesn't. Now, but if I do remove it, then I'm going to use Go syntax at the end of the day. Go removes it, but I don't know. It is just like a aesthetic thing. It doesn't make much a difference. But yeah, Basfit says use kind instead of type. Yeah, I completely agree. That's what I usually write my stuff. It's the way you solve it in Fortran. So yeah, someone says, why didn't you just use type def? Maybe, but it's just, I want the keyword type for other reasons as well. Like I'm adding it for other things, especially the parametric polymorphism. I want the word type. Yeah. How am I doing name mangling? So name mangling isn't actually predictable. It does mangle and they are all unique. The way it does it is if you look at the code in LLVM, ignoring the types here, name mangling is weird. So if you are in the global scope or anything, then it will be a perfect name. So let's go down to somewhere where it isn't. Good. So that's still quite, let's just go here. There's loads of code being generated. That's half the problem. Go back. Let's just guess. There. Nope. Oh. Flipping jellymongers. Here we go. Okay, so we've got the name of the actual file with a unique identifier with a dot and then the name of the procedure. It just mangles it so it's unique. It doesn't worry about that. It's unique. There's no predictable thing. This is mainly because I haven't actually figured out how packages work yet, or modules or libraries work. It's very difficult. What is the compiler written? It's written in C at the moment. I'm hoping I'm going to port it to C++ just for some sanity reasons, mainly. I'm not a big fan of C++ in general, but I literally just need like one or two sanity features. More questions. Can you index through member structure? Yeah, okay, understand. Sorry about that. So QCAS, so bit fields in Odin are a bit different from C. In regards to how they are laid out in memory, I imagine this would create ABI issues. They have probably, well, the thing about C as an ABI and bit fields is you probably don't want to do it at all, is the first thing. So yeah, don't do that. And I don't mean that as rude, just don't do it. But the other thing is, with ABI issues and stuff, you don't really worry. Like, these are complete two different languages. Bit fields you probably don't want to use in production code anyway. They are just there for convenience. They'll be slow because you have to do all the bit shifts, you have to do the clears and then make sure it fits in and do all that. It's not simple in a sense. The last speaker is talking. Oh, do you mean indexing variables? through the actual index? And the answer is no. Explain to me how that would work, like syntax-wise. It doesn't make any sense. The only reason I'm doing this, the explicit like .0.1, it is just for accessing variables by the number. If you do have them explicit, it is there if you want literally a like an opaque type of a certain size. Like you want to have an ID, but you want people actually accessing easily. But whatever, it's just simple enough. So you'd think, okay, so name guy's talking about the name language. I think it would be a good to be able to uniquely convert types to identifiers. So you can name angle overline functions by suffixing the parameter types. Yeah, maybe doing kind of like C++ style. Yeah, so you have the type parameters in it. But because I have multiple scopes and each file is a scope, it doesn't work that way. So you need some way to disambiguate between files and their different names, because you could have two procedures with the same name in different scopes, and you couldn't. They may even have the same layout, like same function layout and calling convention and everything. So it wouldn't work. So you need some way to get around it. If you're going to interface with this language, you probably just want to set what the link name is to begin with, and that's a much saner way of doing it. When will you continue work on the custom backend? Actually soon. This is kind of also part of what I want for the future. The custom backend is planned for when I've got the language pretty much done, and it's nearly there, honestly. Like most of the core features are nearly there. I want to get some of the parametric polymorphism done, mainly so you can have some generic-ish like functions, like a sort function built into the language, and maybe some generic. I hate the word generic, but it's so generic. It doesn't explain everything. It is just parametric polymorphism or paripoly. I don't know what you have to say. Call it parpoly. But into the language because it's useful. Another question: why not make the keyword so that type can be used freely? Like use kind instead, because I use kind as well. They're both as common, in my opinion, as words for me. So other languages use type as a keyword, like Rust does, Nim does. So many they do. So I think people are probably already getting used to it with a bit of Stockholm syndrome. Like, oh, I can't use it. Oh, well, I'm getting used to it. Oof. So why does syntax live matter not matter to you, monster? Well, if syntax lives matters anything like it's what it's used for, I don't associate me with borderline terrorist groups. Sorry. Oh, God, that got political really quick. Didn't me. Sorry. Good God. But yes. So another question, not related to this demo, but could you explain the concept of panic shortly? Odin cannot recover. So panic is pretty much assert at the end of the day. So here is assert, and assert is here. So this is what assert and panic does, and it will just throw a debug trap. So if you go through an assertion, it says runtime assertion at this file, line, column, and here's the message. Panic does pretty much the same, but instead of having a condition when you check for an assert, it just throws. I use this concept all the time, and an assert you just check to see if a boolean is true, make sure it's true. Panic is you give it a message. Unlike Go, there is no recover, because, to be honest with you, if you're panicking, oh God, you've hit something bad. It's like an assert for me. That's how I program, at least. That's just me. Another question. Have you thought about doing stuff like version 0.4 is about X instead of how it is the moment where loads of features and changes are together in one version? Also make it easier to help and talk about features when we know what we're focusing on. Maybe. I don't know, because I always find the thing is I'm also kind of experimenting at times as well. Like, how do I go? You can see how the standard library works clearly. This is just like some of the built-in functions, but it is one of those where I don't know. yeah, this is a bounds checking for error messages. It will just print it out as well. You can see how most of this works. This is all in the preload. But again, I mean, I'm adding features and I don't always know what I want. I'm adding them like, okay, this would be useful to add, or I've always needed one of these, do that, or I'm just adding it as I go along. I'm not being as crazy as JI now, and I don't mean that rudely. I mean, JI is like, it's got all the bells and whistles. It's like a complete C++ replacement, in my opinion. It's better than C++ already, but I don't want a better C++. I want a better C, and I only want it to be a bit simple, not too complex. I can keep most of the spec in my head. I've already got all the spec in my head. I know I've created it, but you can keep all the spec in your head. It's not that complicated. So kind of that way. So but Flydog is asking, would JI generics work in this language? I'm not sure if I want JI style generics because it's implicit. So it'll implicitly calculate what the type is instead of you passing it and telling what it is. I'm not sure if I like that, but I already do that for overloading, so the compiler will figure out what the correct overloaded function is in that scope. Again, it's a thing you need to discuss compared to like the use case compared to actually, is this actually useful? Or would you like to be completely explicit about things? Are you actually, yeah, this is something I want to create? Can panic be hooked so the application writer can do something like calling a message box or printf? Like, yeah, that would actually be pretty useful to have, like allowing the user to change what panic is. But that would require a little bit more going on. But yeah, I could probably do it. And also the user probably doesn't need it. They could just create their own panic, in fact. Like, they could just create their own. It would do the exact same job. So thinking about it, no, there's no need. Have you made progress on adding a kind of logger to the context thing? And yeah, I was thinking about this the other day. So JAI has implemented its location system. So instead of just having macros for, not macros, like directives, constants for file, the line, the procedure, whatever, JAI is allowed to have an entire like a function call which gives you the location at that point. That call, and you can pass it. It's just a variable that you can store. So you can add this to a function. So instead of having an assert like this, you could create an assert, and all it would be is assert. This would be so it'd be my assert. You could have the condition here, and that would be a boolean, and then what you'd have is a default parameter. Now, the Odin syntax doesn't really allow for default parameters. This is because of how the syntax works. It just is. You'd have the location, and it'd be just something like this. It'll be a location type. I don't know. And you'd probably just go like this, and then you go. This is how LLVM does it. No, I'm sorry. GI does it, or GI. I don't know how you pronounce that word. Oof. And if you do if condition is false, you do the same thing here, printf standard error, and you just get the location, you get the file, whatever, you do that, and you just create your own assert. So a lot of the stuff will be built in language, which is better in my opinion. But you'd also be able to pass it, so you could actually create your own logger system instead. You wouldn't have to have the logger system in that sense part of the context, but it would be actually a very useful thing as well. So it's a lot of things to talk about, but changing how the context work, like as an implicit parameter passing rather than thread local storage, would be very, very useful. More questions. I think I'll keep going just for a few more minutes. Question. If a library adds a panic, then I can't intercept and handle it. I would be happy. Well, the thing is, I don't know. This is the thing about panic and stuff. It's one of those where it is where I use the same case as where I use assert. Like, if it happens, you've you've cocked up. It's one of those things like, yeah, you've cocked up. That's how again, this language reflects me mainly. I am the creator, of course, but yeah. Yes, I did talk about a custom backend. I'm developing one at the moment. So this is the custom backend I'm working on. I've not got it all done. I've just designed it in a sense of what I need to do. So it's nowhere near done at the moment. So yeah, I'm just trying to add extra things back into the language. So you can see it blurring across the screen. But yeah, here's the stuff I'm adding. And yeah, it works in a sense. But yeah, okay. Do you plan to abandon the C runtime soon? Yes, but I've tried to do it before. This is not the first time I've tried to do it earlier on. LLVM is horrible to do it. I really don't know how to disable the C runtime in LLVM on Windows. If anybody knows an easy way of doing it, could you please tell me? You can tell me, give me an email here. The email will be, at the moment, the email will be odin@gingerbill.org. That's the current email address that I'll be using. This is not a mailing list, it's my email address. Send me tell me how to do it from there, because I have tried numerous times just to try and get rid of it. It's not helpful. It just is. I don't. So you got not relevant at all, but for the compiler, maybe chat in Odin Discord. Yeah, if you want to do that, you can go to the Discord. So go to the Handmade Network Discord, and it's under Odin. There's a channel, special channel just for this project. I'm so grateful for the admins for giving me it, especially like Yaron and Abner and all that lot. Just thank you. But if you calculate the non-set of a bit set, okay. So they ask, sorry, that's the same question. It says, if you calculate the not set of a bit set, should it just be negating all the bits, or should it be a bit flag, like is not set bit? I'm a little bit confused in my question. Sorry, could you rephrase that? Any other questions left, or shall we call this a night? Is that it? Oh, if I have a bit set only containing one, and I negate it, then bit 33 will be not set, and because the bit set was just 32-bit long. Well, if you just negate, if you're talking about the bit fields in particular, if you negate one of the fields, then it won't change any of the others. You're just talking about that one, so yeah, it'll be fine. But I don't support negating the entire thing. I haven't got those functionality yet, and I don't think I will. Other thing is, I haven't got bit sets as a built-in type either. I'm not sure if they should be built-in type or, again, a user level type. It's one of those things I have to think about it. Question: as library writers, having a common interface to write panics, asserts, log, etc. Towards will not only be swell, but honestly really needed. Yeah, I agree with loggers and stuff, but I don't know about panics and asserts, because again, it's one of those things where maybe I don't know, maybe you can change what the debug trap is. Maybe. Why is transmute not bitcast? Because it's a fancy name. I know that sounds weird, like it's something you're not going to be typing often. When's the last time you used transmute in like a conversation? And then, yeah, it works. So yeah, it's something different. But yeah, that's about it. So, thank you all for listening in. Thank you all for watching. And please discuss. Here's a gist of, I'll put it in the chat for you, of the Syntax Lives Matters debate. Because, well, I don't know what to decide. I know many people like the current syntax, but it has a lot of severe problems to it, like a lot. And I'm not sure if I should just go to the new one, and I'd love a discussion because it's the way I like figuring things out. Like, discussing with people helps. It's the way you find out information. And yeah, it's just that. So thank you all for listening. And I should be able to get this version released tonight for you, so thank you very much, and goodbye.